Hey guys, Coach Sharp back here. This is the last video on the volume worksheet, doing the last 6 word problems. So let's jump right in. All right, number 7. Just trying to use stapler as paperweight. Just making a little bit of a shout out. A sandcastle with the shape of a pyramid with a square base has a volume of 40 cubic inches. The base has an area of 25 square inches. What is its height? So we're dealing with a pyramid with a square base. Again, we've seen a couple examples like that in this worksheet. Like this is one. It tells you it's a square pyramid. So you know the base has to have length and a width that are the same. But what we can kind of do, again, if we look at the original formula sheet, this is what you're actually going to get. It's not going to have the... I never wrote this down, so let me do that real quick. It's not going to have the 1/3 length times width times height on there. It's just going to have this. So that actually kind of helps us out here. So I know the volume is 40. Okay. So it's 1/3. And y'all notice I didn't draw the picture with this one. Again, you don't necessarily have to draw the picture if you can figure it out. So 1/3. I already know the base is 25 square inches. And then times the height, right? Okay, so again, what I would kind of do here is I'll put this over 1. And then I would have 40 over 1 equals 1 times 25 times the height is 25h over 3. I would cross multiply. Just give me 120 equals 25h. Divide both sides by 25. It should give me a height of, I believe, 4.8. Let me do the math in my calculator. 20 divided by 25. Yeah, 4.8. Okay. 4.8 inches. Here we go. All right, 8. An antlion is an insect that digs cone-shaped pits in loose dirt to trap ants. When an ant tumbles down to the pit, the antlion eats it. A typical antlion pit has a radius of 1 inch and a depth of 2 inches. Find the volume of dirt the antlion moved to dig its hole. So as you can see in the picture, it's a little bit of a cone. It tells us the radius is 1 inch. So I got that there. The depth is 2 inches. So that's actually going to be our height. It's just the cone kind of flipped upside down, right? Okay. So I got to get the volume of a cone pretty much because that's the amount of sand, the volume of sand right here that was moved to create the cone shape. So 1/3 pi r squared h. 1/3 pi r squared h. Radius is 1, height is 2. So this is going to give me pi times 1 squared is 1, so that cancels out. So just pi times 2 divided by 3. So I know this actually looks like pi times 2/3, which you can basically do the same thing. So I'm going to do pi times 2 equals divided by 3, 2.09 inches cubed. So 2.09 cubic inches. Mr. Sizemore's head could be considered a half of a sphere in a cylinder. So I guess that's the name of the minion right there. Mr. Sizemore's head has a diameter of 8 inches and a height of 7 inches. How much hot air can it hold? So again, we've seen that's actually the 2 half spheres. Do we actually have one where it's a cylinder and half sphere? There we go. Way back over on the front. cylinder and half a sphere. Right? So again, to do half the sphere, I'm just going to calculate the whole sphere and then divide it by 2. So I'm going to draw this one out and then I'll show the math. So let's see here. Might take a second while I'm drawing it out. All right. All right, so I drew the cylinder. The diameter is 8. Again, need the radius, so I know the radius is 4. The height is 7. Okay. Then half a sphere. All right, half a sphere. Again, it's going to have a radius of 4. Okay, so there's the cylinder, there's half a sphere. I know the half sphere doesn't look great. So number 9. Alright. So the cylinder is, again, pi r squared h. So pi, radius is 4, squared times the height, which is 7. Again, you can punch that in your calculator as is. It's going to actually be 4 squared is 16 times 7 is 112. So 112 times pi, or 112 pi, 351.86. And again, it's got the double apostrophe, so we know it's inches. So cubic inches. So if I were getting a whole sphere, it would be 4/3, need paperweight again. 4/3, I know it's making a shadow. Pi, radius was 4 cubed. So again, I would be 4 times pi times 4 cubed. So that's really 4 to the 4th, which is 256 times pi divided by 3. I'm going to get 268.09. That's the whole sphere, so I had to divide it by 2. I feel like we already actually had this on an earlier problem. Maybe I'm wrong. Or maybe it was on one of the practice tests. I'm not sure. So 134.045, which we could just round that up to 134.05. So we got that. We'll add it to the 351.86, which is going to give me 485.91 cubic inches. So there's number 9. All right, number 10. Half an orange below has a diameter about 3 inches. How much pulp's inside of it? Again, we're going to assume half orange is half of a sphere. Diameter is 3. Cut it in half. Radius is 1.5. So if I do 4/3 pi 1.5 cubed, again, that would be the whole sphere, and then I will take half of that. So 4 times pi times 1.5 cubed divided by 3. I think we actually did that in the last video. I do see it. That was, we actually did that one in the last video. I think it was the snowman problem. So that's going to give us, when I do all that math, 8.32 cubic inches. Now I'm just going to divide that by 2, which give me 4.16 cubic inches. So again, it's kind of using the, use what you've already done, help you out. We already did that work, so don't have to necessarily punch in your calculator again if we already got it. All right, mixing bowl is approximately half a sphere. How much will one hold if its diameter is 15 inches? So again, another half a sphere, diameter is 15, so the radius is 7.5. So I got 4/3 pi 7.5 cubed. Don't think we've done this one. So 4 times pi times 7.5 cubed divided by 3. Again, I would do the 4 times pi times 7.5 caret, give me the exponent third power. So 4 times pi times 7.5 cubed equals 5301.44. We round it. Divided by 3. So 1767.15. Again, we were rounding that. But again, that would be for the whole sphere. So that's cubic inches. Again, divide that by 2. Would be, I erased it from my calculator, so again, I'm trying to do this in my head real quick, would be 883.575, which is around, we could just round up to 5/8 cubic inches. Okay? All right, number 12, last one. When first built, the largest pyramid in Giza, Egypt, had a square base with edges of 754 feet and a height of 481 feet. Over the centuries, some of the stone has eroded away and some was taken for newer buildings. The pyramid today has base edges of 745 feet and a height of 471 feet. Find the difference between the original and current volumes of the pyramid. So I just gotta get the original volume, current volume, and subtract them. So again, I'm gonna come do this over here on my paper. It's the same formula, okay? Again, square base. So length and width are both 754, height is 481. Now here, length and width are both 745, height is 471. Formula for a pyramid, 1/3. Again, this one I'm gonna use the 1/3 length times width times height. So the original pyramid originally when it was built, 1/3 times, what was it, 754. So 754 length, 754 width, 481 height, 481 height. Again, you can really just multiply those. You can even do 754 squared if you like, 481. And then divide the whole thing by 3. So let's see here, it's gonna be a little big of a number. 754 times 754 times 481. That number on its own is 273,456,196. Divided by 3 gives me, again, trying to count it out, so 91,152,065 and 1/3 cubic feet. Okay, and so we'll do what it is now. And same formula. We've lost 9 feet on each of the length and width, 10 feet on the height. So again, 745 times 745 times 471 divided by 3. It's going to give me, let's see here. All right, 745, 471 gives me 261,416,775 divided by 3. 87,138,925 cubic feet. Then subtract those. Okay, it's going to be just over 4 million cubic feet. Let me subtract it. 91,152,065.333 minus 87,138,925 equals 4,013,140. 4,013,140.3. Repeating. Again, you need to show all that work, but I got